NEC Table 220.12c provides the general lighting load in volt amps per square foot for various types of structures. The table values do not take into account the type of load, whether it is continuous or non-continuous. NEC Table 220.43b provides the demand factors for general lighting systems based on the total connected load. The demand factor is a multiplier used to reduce the total general lighting load calculated from Table 220.12c. NEC 220.43b states that for continuous loads, such as those found in restaurants, the applicable demand factor should be 100%. Therefore, the demand factor for a restaurant would be 1.0. Here is a procedure for calculating the general lighting load. Firstly, determine the type of structure, for example, a restaurant. Secondly, use Table 220.12c to calculate the general lighting load in volt amps per square foot. Thirdly, multiply the general lighting load by the square footage of the area. Fourthly, use Table 220.43b to determine the demand factor for a continuous load, which is 1.0 for restaurants. Fifthly, multiply the total general lighting load by the demand factor to obtain the design load for general lighting. Let's go through an example. For a restaurant with a square footage of 1500 square feet, the general lighting load calculation would be as follows. The general lighting load from Table 220.12c is 2 volt amps per square foot. The total general lighting load is 2 volt amps per square foot multiplied by 1500 square feet, which equals 3000 volt amps. The demand factor from Table 220.43b for continuous loads is 1.0. The design load for general lighting is 3000 volt amps multiplied by 1.0, which equals 3000 volt amps. Therefore, the design load for general lighting in this restaurant would be 3000 volt amps. It is not necessary to multiply the general lighting load by 125% as the demand factor for continuous loads is already accounted for in Table 220.43b.